Hello, hello. One second as I'm just getting everything set up here. So I know I said I would do this yesterday, and I'm sorry that I did not. But just checking the sound here. Cool. So it turned out, I could not figure out what was wrong. I was having just a real, absolute, terrible time. I read through all of the multi-core documentation. That's to recap for anyone who did not see the stream 2 days ago. We were working on trying to boot the second core, the second processor inside of this operating system that I've been working on. And so we were working on sending these what are called interprocessor interrupts. And if you will remember, the last time that you saw this, it would have been a lot shorter because I have just, as you can see, I've just like bucketed on crazy amounts of debugging code. I could not figure out what was going on. It just nothing was working, right? I would send the IPIs and they just wouldn't change the state of the processor. I was looking at the manuals. I was reading other people's, like I was reading the Serenity OS source code and the Tuaru OS source code, like just trying to find something that I was doing wrong. These have been changed out. I used to have high level functions. Now it's just send a raw 4500. And just nothing was doing anything until so I started printing out, what is the value of these registers? Well, I see that they read as 0, but that's totally believable. A lot of sort of hardware registers, you write to them and you get a value, but you read them back and you get nothing. That's not abnormal, so I wasn't too alarmed by that. But it was, now I feel like the stupidest person ever because it turned out that I just had the wrong address. I had one fewer 0 here. So I finally added this like full on, we're doing this right to this register. The mapped address is this. I had to write a function that resolves virtual addresses, and then I run it. And it says, oh, you're writing to, you're writing to the wrong address. So now it works. I did so much debugging. I was just writing to this address, F0 FEE instead of FEE. So, but I did so much debugging that as soon as I add this 0 and we run in monitor mode, give that a second to start up. And there we go. Well, now it isn't, because I didn't rebuild. Really not doing my case justice here. Or maybe I'm proving the point. Hey, there we go. And look at that. It actually changed state. It's in, so it says it's at IP3, but that's because the code segment is 0800, which means it's executing at 8003, which is exactly where I put the code that I expected it to be running. So that is working. We have successfully initialized the second core. It's not ready to go. It hasn't been set into the right state. We haven't initialized paging or anything. It's still sitting in 16-bit mode, which I don't actually know how to tell from this output, because this is obviously giving us the extended registers, but that's because you can get to the extended registers in 16-bit mode. So I'm not sure how to tell that this is 16-bit mode from here, but I don't know how much it matters. I know it's in 16-bit mode. So that is the resolution to that. I don't know what I think I definitely do want to take a little bit of a diversion here, though, because that took a lot, and now I feel real bad about it. I mean, I'm glad I didn't sit here on stream and just, stream me hitting my head against the wall for the last 2 days. At least I've spared you all that. But I really don't think I want to do the next stage here. So I think the first thing that we are going to do here on stream is commit this, which means getting it looking a little bit presentable. And then I've got a couple of other things that I'm hoping to look at that maybe we can make some really interesting progress and some really interesting improvements to. So let's make this a little less terrible. For starters, not using the internal functions. I'd also like to see if we can use my real high-level functions again instead of these raw IPIs. So what would that be? That's init and send IPI delay. Hopefully this can be a shorter delay. SIPI. And that should actually be fine. Hey, Laser Kitty. Yeah, go ahead. Please, I'm always happy to hear questions, and no questions are dumb. The red line showing my desired column is the color column command. Set. It's a set variable. Color column equals, and then if you set it to 0, it goes away. If you set it to 100, it's at 100. If you set it to 80, it's the 80th column. 10, it's just color column. And then the way that you get the color you want is it's a highlight rule. I don't know that I have set it. I have set it. It's this highlight rule, highlight color column, C term. Well, you can use any highlighting rule you want, but in this case I've set background equals dark red in terminal. But you could, this just matches any, just like here, right? I tell it line numbers are foreground dark gray. I mean, you could make the line foreground if you wanted to, but it's color column. So now we are hanging, and I bet I know why. I wonder if we're hanging on one of these. I So I made, one of the things that I did was make this really convenient delay function so that I didn't have to write this crazy for loop all over the place, but I never actually used it in the LAPIC code. So I think we're just going to put that as a, just going to make that an inline. Oh, that's not it. Just so that this is available everywhere and I can use it from everywhere. I mean, it's kind of it's a very naive implementation, but it's something. We're sort of estimating that it's approximately in microseconds, which is not great because it depends on how fast the CPU is, but it at least prevents me from having to write this all these times. Well, it's also not helping that I sent an IPI to this processor to test. This is why we don't commit without verifying that things actually work a little bit. And now because I changed the basic header, we have to compile everything again. But that's fine. I really need to get a better... This is currently running on a very small server, so that's why that takes so long. This would normally take just a couple of, well, like half a second to compile the whole thing. But ever since I moved my computer, my current laptop is an Apple M1, so it's ARM based, and I haven't been able to figure out how to build. It's not that I can't run the emulator, that's fine. It's not that I can't compile all of the software, that's also fine. And I have it compiling on this machine. The one leap is this building an ISO image with Grub, because I use Grub to make basically a rescue ISO image is how I build the final CD-ROM bootable thing. And that package is not available on macOS at all. It's certainly not available cross-compiled, and the only instructions I can find to cross-compile it are very gnarly looking and involve building custom copies of GCC, and that takes hours, and then when you want to debug it, it takes hours more because it's a custom copy of GDB. Yeah, for everything that is not, for everything else, like any application code, it just works. It's really nice. Like if you download an Intel macOS DMG from the internet, it's great. QEMU is an emulator, right? It's designed to run code from other architectures, and you could run like a Linux ISO in QEMU. You don't even need Rosetta at that point, right? You're running a Linux x86 ISO inside of the emulator QEMU, which is natively running on ARM, and that also just works. That's quite slow because that's how QEMU works. QEMU is being an emulator. It's very slow. I mean, it's very slow as I'm using it here. The only thing that I can't get to work is that building step. That depends, as far as ARM-based VMs, that depends on what you're looking for in a VM. If by VM you mean virtual machine, the nearly native speed, right? Like if you run a VM in VirtualBox, for example, that's really fast, and you can do that, and it'll need to be ARM-based. The other way, right, emulated, you can run anything, right? QEMU system supports all of these different. You could run a AR64, that's ARM. You could run an Alpha operating system, an ARM operating system, a HP operating system, 68K Motorola operating system, MIPS64, PowerPC, Spark, x86. But if you do that, it's going to be slow because that's not virtualization. It's not hardware assisted, right? It's a CPU that's emulated in code, as opposed to where virtualization is basically sharing hardware resources with the host. And you can only do that for the same architecture. Does that make sense, or am I just waffling? That is the distinction. Okay, good. So why is it now hanging? What have I done? Let's get rid of some of this ridiculous debug output. Yeah. Well, the challenge there is QEMU is the primary interface to doing virtualization on Linux, right? If you want to use KVM, you use QEMU. I think you actually do use QEMU system x86 dash enable KVM or something. Yeah, so I'm not going to be able to do that. This is a virtual server already. I'm not going to be able to run a VM inside a VM. But this is virtualization, even though it's an emulator. But if you don't do enable KVM, it's emulating. It's very confusing. That's a little ridiculous. I think this is a little ridiculous. Yeah, okay. Then, yeah, exactly. You know what I'm talking about. Okay. So I'd really like to know where we're stuck. Okay. So my guess is that we're stuck here in await delivery. Let's just like do a little XY print there to see that every X has a Y. And we got an X and we don't have a Y. So we definitely know that we're stuck here. Which is interesting. And we weren't before. Well, okay, we weren't before because we weren't using that code before. No, we definitely were. We definitely were, because we were calling send API raw, which definitely does await delivery. And we were setting that bit a second ago because we were calling send API raw with, it was 4500. And 4500 is I think. Oh, maybe it's not 1 to 12. Oh, it's assert, not 1 over 12 is supposed to be the bit that is set, and you wait for the hardware to unset it to tell you that the operation is completed. But 4500 doesn't have one of those. That's just the assert bit. I mean, I could definitely not. Just really by doing this. And I'm not setting it there. So let's at least make sure that doesn't hang anymore. It does not hang anymore. Make sure that we're still starting the processor. Info registers A. We are. Okay. So we're starting to look a little better here. I am happy with this for now. And then the last thing that I wanted to try here was I switched off my nice and beautiful, real memory model for this volatiles because I was trying to copy what other people were doing. And I want to make sure that this still works. And if this still works, then we're committing this. And moving on. And it does. Beautiful. We got the delay in basic. We added 1, 0 to this stupid constant. We unstaticed a couple of... I would like to put those back. I want to... I'm really trying to make a concerted effort to keep my private functions private, but the problem is inevitably you need to call them from somewhere else to debug something. So like even this is supposed to be static, but I think I even added that to the header. Nope, I did not add it to the header. Okay. Still compiles. Still builds, still runs. Delete, delete, delete. Cool. Epic. Used. Right. Cool. Have a good rest of your day, Laser. See ya. I would like to back out the VMM resolve change, but I'm not going to do that because I don't want to undo this commit now. I don't mind changing commits with amend and stuff, but I really don't like sort of completely undoing it and like backing a change out. So I think we'll just note. Because it's only a 2-line function, so I'm not really that concerned. All right. Up. Oh, because I restarted my machine. There we go. So why is this not working? SSH keys. All right, now we have to rebuild everything, and then we're off to do other stuff. So first thing I want to do, very low-hanging fruit, is I want to write a program that clears the screen, because I do that a lot and it frustrates me that I can't do it in the system. So let's find the ANSI escape code to clear the screen, and let's just write a program that prints it out. It is up, down, back, erase. Here's part of the screen. If n is 0, cursor to end. If n is 1, cursor to beginning. If n is 2, clear the entire screen and move the cursor to the upper right. This might be correct. We'll try it. So CSI is escape, control sequence introducer, escape open bracket. And so it's CSI 2J. Writing Rust earlier, so now I'm going to be my fingers are going to want to type print line every time. Escape is 1B. There's a way in Vim to reflow text. How to reflow text. Go away, Stack Overflow. It is GQ. I don't really want to do everything, but visual GQ. There we go. So that took my text width of 80 characters and reflowed this block so that these, now that I'd added something up here, reflowed it so that it fit. And that should just work. And it super didn't. We could be really nice. Technically that requires standard library though. Exit success is just a shorthand for 0, but it's technically more portable. Really, that's not really that big of a... Okay, that didn't quite do what we had in mind. Clear puts the cursor up there in here. So I wonder if we can just find out what clear is doing if we just strace it. Okay, so clear. So this is the Linux system calls that the clear program is doing. All of these are like the standard library, setting up the malloc heap and stuff. But it looks like what it's doing. Interesting. So it does not set anything through IO controls. It does get the information about the terminal. It gets the window size, which is potentially I don't have a way to get the window size right now. So if we need the window size for this, it's going to be kind of annoying. So you see it, this IO control returned that the window size is 48 by 189. But then what it sent was escape H, then 2J, then 3J. So what does that mean in the context of this? 2J we know is clear entire screen. 3J is clear entire screen and delete all lines in the scrollback buffer. And H is move the cursor to with nothing, one base, and default to top left corner of embedded. Okay, so we're basically just gonna do that. H, and then I don't know why it sent 2J, 3J, but we can just try 3J and see if that works. That probably was unrelated. Ah, okay. So that's also interesting behavior, that if you don't send 2J, it doesn't clear the screen. It actually just moves you. So 3J, I guess, deletes scroll back, but doesn't. So we really need to send all three of those. 1B open bracket 2J. And then I really like to, I really don't like to like leave these like this. So I'm going to just give some little defines. So H was, what was H? H was move cursor to top left is X 1B open H. Clear screen was 2J, and then clear scroll back probably was 3J. And then, so then now, because in C, if you have strings that are just sitting next to each other in the file, they concatenate. So now we can call this as move to top left, clear screen, clear scroll back. And so those defines will text sub in these strings. Those strings will swish together. See, there's no commas here. I'm not doing any formatting or anything. And then it'll give us what we wanted, hopefully. And it will. And now if we look at the last output, it's going to get really confused probably, because it's going to contain literal clear screen characters. Well, okay. Less is smart enough to print it well. I think Vim would print it well as well. Yeah, Vim is smart enough to print these as literal escape character. But if we like cat this, it's gonna delete our terminal. Cool, awesome. So I think that's a feature. We've added a feature. Think clear needs. Kind of interesting to know if clear has a dash dash help. It does actually have a dash dash help. Do not try to clear scroll back. I'm gonna guess if we strace clear dash X, it's only gonna send yeah H and 2J. Very interesting. Well, I mean, we could, if we felt so inclined, we could make a little user interface. I think that might be kind of interesting, actually. I think it's time that we change the name here. Change the stream title. Just so we don't lie to the people about dual core. We already did that. So let's see if I can remember how to use getOpt, because I'd really like to do that. I know uname, I think, is a good, yeah, here we go. So getOpt is a standard C function. Well, not this getOpt. Man, 3 getOpt. GetOpt in section 3 of the manual. Section 3 of the manual means C, like library function calls. So this is a standard C function, and it's one that I have implemented an implementation of. I have a version of getOpt in my C library in libc getOpt, and we're going to try to use it to get some command line arguments for clear. And so how does this interface work? This interface works by repeatedly calling this function getOpt. So it's got some internal state, very C-like. You give it the argc and the argv. You give it a specification of the valid commands, of the valid letters. So in this case, the valid letters that I've said are right A, S, N, and then that gives you the thing that it returns is the character that you got, and you then switch on that and make some change, right? So in the case of this uname program, I'm setting flags in this integer because I had a whole bunch of things and I didn't want them to be Booleans. In this case, we're probably going to be a little simpler than that just because I'm not feeling that. But we could say like clear scrollback is true, right? And then while get our character, and then if we don't get something we expect, we're going to call a function called help. We're going to move this now into 2 prints. So that we can conditionally clear scrollback or not. And we're going to have a function called help, which prints and I think that's basically what we want to do. We want to say, what is this program? Which we certainly could do. It is often done that you pass the program name so that we can indicate like how this program was called. Which that doesn't really make sense. But what I'm saying, so the name of the program is passed to the program in argv0 by typically. That is not hard and fast, as we learned recently because there was a vulnerability in a major open source project caused by assuming that argv would always have at least one thing in it. In this case, I'm okay making that assumption because I made all of this. And so in the default state, argv0 is going to contain the name of the program. That's set by shells and stuff. And so what I'm saying here is argv0 is the name of the program. When we call help, put the name of the program in the variable name, pass that, and print it out in the help text so that we can show how you invoke the program. We're not saying like, oh, this is something else. And we should be able to see that in a moment. If I run this, we should be able to see it say, I should be able to move it to a different name. I think I can do that and see it change. Okay, it did not like that. It did not like that because I do not have a variable called C. It did not like that because I don't have a library called getopt. It did not like that because it's not called getopt. It is in UNISTD. It is not in a header called getopt. So maybe it's not actually C standard. Unisted is usually for sort of Unix standard functions. Okay. So now if it's I would have expected that to return 0 and just not run the loop anymore. Clear -x, clear anything. Clear is just clearly not working. I wonder why that is. So I would have expected if there were no more arguments for getup to just return 0, right? C would get 0, the equality would return 0, the while would just bail out at that point. Maybe I should initialize that to 0. Maybe there's something weird going on with the uninitialized variable. I wouldn't expect that, but can't hurt to check. Nope, it's not that. Maybe this is going to tell me there's some sentinel when you are at the end. No, I mean, this example here is pretty darn... no. I have missed something. I've missed this. When you get to the end, you get -1. That is why it's not working, I presume. Clear? No, we're still getting something. So let's go ahead and just print out C is C. So we got X, and that was fine, and then now it's giving does not equal 1, does not equal minus 1. I just can't read. Or right. There we go. Clear dash X, okay. And that's actually kind of an interesting no, okay, so I do not print in my strace where the Linux strace program is actually resolving the string out of this, and I would really like to get there to say, hey, this is a string, we should print the value of that string, or more accurately, I want to get there in trace, because trace is the real user mode one. Trace is much more analogous to Linux strace than my program called strace is. I just have too much muscle memory to change which one is which at this point. But trace is doing this all in user mode, and strace is this is some magic kernel bits, and I don't want to have more magic kernel bits. But as you see, the user mode one is really not giving particularly informative output. I mean, it's useful in the sense that you get the same information. Actually, you get a little bit more information out of trace, because trace will also do things like signals. So if I was to trace, say, a shell and then hit, well, Control C is a bad example because it exits the whole thing. If I traced a shell and then hit Control X, I do think I understand why this happened. It did crash. I do think I understand why that happened, but you see the tracer program got to see signal 9, signal 14. So you get actually more information out of this. You get, yeah, syscall entry and exit separately, and then signals is the only other thing that I'm actually tracking right now. I wonder if are there any other states? Yes, so there's one other event. Oh no, there's two other events. There is a trap event as well, which I will talk about in a second because that's super cool. And then there's new Tracy, which is just saying like, hey, you have a new Tracy. You're getting a new, you're tracing a new process. You have a new trace child. The trap one is not used by the trace program, but it is used by the step program. And step does this is like a debugger, right? These are single steps through user mode. And I think it's just so cool to see it. And then I have it resolving the function names. So we can actually see what the process is doing, kind of like you would in a debugger. And if this was actually a debugger, you would say things like, oh, break on this function. But what we see is, we're in, we're trying to do printf, right? We're in VS printf. That needs a length of a string for something that took this many instructions to run. Then we're back in VS printf for this many instructions. Then we have, we're back in printf for this many. fwrite is doing some, and then mem copying, and then it's writing lines to file. It then does a syscall. So it goes into write syscall, which calls syscall3, which calls the write syscall, goes into the kernel, syscall enter, it comes back out of the kernel at syscall exit, backs up the stack, right? Write lines, write, syscall, write lines. I think that's just, it's super cool that this works. I don't know. And this is two user mode processes talking to each other. I mean, the kernel is involved because the kernel is like setting the trap flag and getting it to exit every time it runs an instruction, but it's just sending signals to another process. This is not kernel assisted necessarily in terms of, it's not the kernel printing all of these. But this is a digression. What we should do is print that we, or make a commit that we improved clear. Improved clear with optional scroll back preservation. Or something like that. There's a couple of things that I feel like we should maybe even get rid of in here. Unfortunately, I have a lot of, I know on the stream a couple of, maybe a week or so ago, we were looking at the network stack. That really does need a significant overhaul, and there's really an unfortunate amount of networking programs in here. I think something I'd really like to do is just get those out of the main, just because a lot of them have very short names. Things like DG, well, that means it's a datagram socket tester, DG. SC is a stream socket server, I think. SC, like, they just need to not be like that. So DG is definitely right. This is definitely sockets, socket, AF Unix, sock datagram. Let's go ahead and move that to user net datagram.c, or maybe even like Unix datagram.c. What else? What else do we want to move? What is SC? SC is a socket. I think it's a stream connect is what I think we would call it. But then what's ST? ST is a stream. This is a lock, listen accept. So ST is a stream server. So let's go ahead and move. I probably won't leave these this long, but I at least need to be able to understand what they are. What else? BG is background, that's fine. Is there anything else that just doesn't work? What is MB? Oh. MB, I should really rename that too. It's a Mandelbrot drawer. Draws the Mandelbrot set. I don't think it's going to work right now because I don't have a math.h. But it draws the Mandelbrot set. I wonder if we can bring that back. That would be kind of a really interesting user mode thing to do today. Yeah, so I removed it in this commit. Remove libm, I'll make my own. I then decided not long afterward, it became clear to me that was not possible. I cannot make my own libm. So I think we should just undo this. External. And well, okay. So it's definitely not going to live in external slash. Well, maybe it will. I guess we have to decide where it lives if we're going to bring it back. I do want to grab, this is another thing that we talked about a couple of days ago, is my better log format in Git that I had in a different machine. I found it, and I just haven't put it on this machine yet. And I definitely don't want to show the name part because they're all me, and so it doesn't matter. Now, yeah. So now GitLog is more useful because it shows the time. So we were curious when external was deleted. The answer, it was deleted 1 year and 1 month ago. Fantastic. This is definitely a makefile project, so that might be interesting to integrate. Because I don't use makefile anymore. We might play with this in a bit. I do definitely want to get rid of these programs. So no datagram, no socket connect, no socket. This was GQ to reflow. And yeah, so AB is fine. AB is an AB test. Honestly, args should probably go. That's kind of a very out-of-date testing program. BF and BF2 are brainfuck interpreters. BG spawns a process in the background. That's, I mean, it's not really necessary, but there's no reason to get rid of it. Bomb is a fork bomb. It's useful for seeing that I get some sort of useful out-of-memory behavior. Busy just sits there in busy loops. I do not use it right now. And it's got a very old version of string to decimal. Yeah, so it's just... There's no reason to get rid of that, though. CForks is a very useful... It's a threading, it's a multi-threading test. Chmod is chmod, no reason to get rid of that. Clear we just made. Clone is another multi-threading test. Column is very useful. It's a columnar output formatter. Crash is a it's a crash behavior tester. Create is a multi-threading test. Echo is echo. False is false. Float is a floating point test. Forks is a multi-threading test. Head. I don't think I realized that I had written a head. Well, I mean, it's a version of head. It's got a very short buffer. Unless it's, I don't know if this will even work anymore with the way that I've done input and output buffering. We might have to test that. That might go on the to-do list. Init, ins mod kill, ls, mmap, mod sys, rm, rot13 sleep, step, strace, test. Yeah, all of these things are good. We've gotten rid of the networking stuff, so this should now build. Take a second because it's got to rebuild everything, but it should now build. And those programs will just sit in that folder, which is exactly what I want them to do. Rename those to Unix Datagram, Unix Socket Stream, Unix Stream Client Server. And that's exactly what I want to commit. Just to get them out of the way, to know that everything that I can run in the system is like a useful thing to do. At least vaguely. So libm. Libm. That'll be very simple. Probably. We might have to set some flags or something. Let's see what we had to do for the CMake list for libc. Just add the library, install it, add a dependency, and install the library. So we'll need to get the list of sources from the make file. The library is called m. There is an libm dependency on libc, and we want to install the library m. This is going to be libm sources. And that is done with set. And then the real question is just what kind of crazy stuff is happening inside of this make file, and do we need to do anything else? Because we might need to set some flags. There are potentially flags. There are some flags. Yeah, we need to tell it it's C99. We need to tell it the include directory, though that we'll do that in CMake. We do need to tell it about these flags as well, these defines. We'll do that in CMake as well. Okay, so Arch, so we have a couple of different sort of categories here. We have the architecture sources, the common sources, and the complex sources, which are in different folders. And we're gonna bring that all, I think we're honestly just gonna make one big happy family. I think a lot of the reason for this is that, yeah, they have the Arch i387 versus Arch x86. I think for right now, we're just gonna say, okay, so libm sources is all of this. Get rid of any get rid of all of those escaped new lines. Like that. And then all of these are in Arch x86_64. And they get indented. That's the Arch sources. The common sources, we'll have to figure out where they are. I'm not sure exactly. You see how much stuff there is. This is why I can't make my own libm. Common sources, we can just get rid of all of those later. Common sources do not necessarily indicate it's in src, I think. Yeah, they're just in src. That is a lot of files. And then the last part is libm/complex, which are the complex sources. Complex. Complex. Get rid of all of these again. And let's indent everything properly. Cool. That's all of the source files that we should need. What else do we need to do? Well, we need to set some defines. We need to how do we set some defines? CMake add compile definitions. That's going to be very important. So we need to add compile definitions for all of these feature flags, which are down here. We need to set CMake flags to all of this as well. So let's go ahead and grab, oops. Let's go ahead and copy all of this just to let us keep an eye on what we need to add. We need to add multi libm equals 1, POSIX mode equals 1, use sortix equals 1, and then we need to set CMake flags. We should be able to use the C flags from the rest of the system. There should be like an add C flags. I'm going to add a C flag. No, the only time is I set CMake flags to kernel C flags, or yeah. Surely there are, I thought there were definitely user mode flags that I was passing, but I certainly don't see where those would be. Maybe it's not as big a deal as I thought it was. All right, well, let's go ahead and just set these C flags. So that is not entirely clear to me how that's supposed to work. Okay, so it should be just set CMake flags dash standard equals new 99 dash w all extra. Here's where okay, add compile options is what it is. Yeah. I knew I was missing something. So I definitely set some C flags. All right, that should be everything we need out of, no, we still need to add an include directory. And we do that. Include directories. Include directories, include directories, source, include directories, arch, x86, 64. That is everything we need out of this. Now, does it work? Well, we have a lot more files to build. You see there's now 513 files. So we should really make this optional because... Okay. So... what are you upset about? Oh, you're really not getting the right headers. Okay, so this is definitely not getting the right headers because this is like upset in the BSD macro. Yeah. So like this should be what? RCSID. Well, that's not very helpful. Something with a space before it. It is in source sys cdefs. So that should, if we run make again to figure out what file that was, this should just include source cdefs. And we can investigate this to see if it's doing... It's definitely including external libm include and external libm source. And then fnv.c should be including source cdefs, and it is. So why would that be upset? And then it's also including assert, so I'm a little confused as to why assert would be. I guess they define their own assert. Is that what I'm interpreting here? Because this is saying assert expands to assert exit in include assert. Is that my header or that is my header? Okay. Assert exit expands to exit. So surely this then needs stdlib.h. Okay. Nope, that did not help. That is now rebuilding things in the kernel. Okay, well that did help because it's not quite as bad anymore. Except that this source sys cdefs, it should, if not defined RCSID, define RCSID to nothing. I wonder if it could be related to the fact that it's trying to do an include next. No, it doesn't look like it. Define RCSID nothing, and then for some reason that is annoyed. RCSID of a parameter to nothing. Type specifier missing. Let's see if we're missing anything else from the make file. Just sort of a scan. Arch source, comment source, complex source. That's the objects. We're not using i386. The compile command is, we haven't dealt with installing headers or anything like that. We definitely will have to, but that is a later problem. We might need to set, I'm curious where this fpu.h is coming from. We almost certainly need that to be somewhere. Yeah, but we're including Arch subdir as a header, so that should be fine. That's in the include directories. Yeah, you can see it here. Include Arch x86-64. This is, incidentally, it is setting standard C11. And in fact, yeah, but it's setting standard GNU 99 and then standard GNU 11 even later than that. So really, who knows what's going on here? Why is CMake inserting GNU 11 there? I wonder if I have told it that we're using C11 and that's why it has done that. I set standard equals C11. I never set GNU 11. If I grep for 11, I'm going to get, okay. So I set CMake C standard 11 somewhere else. Let's go ahead and turn that off. Oh, I did that right up at the top because I'm setting that elsewhere anyway. I don't expect this to make any difference whatsoever. But we can at least I see. Well, yeah, we're not doing that anymore. We're gonna reset that. We're actually just gonna get rid of the, there's no point in passing that compile option, and there is no point in passing this compile option. We're just gonna use C11. Can't use C99 because my headers for my C library, my headers are definitely super C11, so I can't tell this library to compile as C99 or else it just won't work. And honestly, telling it to do WAL is not very helpful either because it's already being built with WAL. That's already in the default set of options. And we're still getting this. These are wrong, incidentally. These defines. I guess I just don't need commas. But I don't think that would make a difference because the only thing that would be checking is whether they're defined or not. So we've got all the right include headers, right? We've got the real include, the build include, libm include, libm source include, libm arch include. We've got all of the errors that we care about. We've got all of the necessary warnings. Standard is correct. We're compiling the right file. And the header definitely says the thing that we expect it to. So why don't we, let's go a little more directly and say RCSID of anything is nothing. Okay. That has changed the behavior. To worse behavior. Is there? How do you make a statement at global scope go away? I feel like I've done this before. I've definitely done this before. How do you make a statement go away with a semicolon? Static assert has a semicolon. Okay. Well, no, that hasn't done anything because I've just bumped the version timer and it's going to rebuild all the files. Is this the same one? It is the same one. Static assert with no message is a C++ 17 extension. Okay. So that appears to have worked. I have no idea why. But I mean, we can operate with that just by I mean, and now that doesn't work for these. Why? Okay. We're still including source CDEFs, which should definitely be coming from there, but I guess let's check that I don't have a version of that. I do have a version of that. It has nothing in it. I wonder if that's... because it's doing an include next. I wonder if that includes next and doesn't include. That doesn't make a lot of sense, but it certainly can't hurt to try that. And that has improved the situation. Misleading indentation on line 91. Wow, that's horrible. Honestly, though, what I'm going to do there is I'm going to say, because I'm really not interested in fixing that kind of problem. I'm going to say, do not warn me for misleading indentation. Let's make sure that's the right function to call. It is add compile options, not add compiler flags. Add compile options. Okay, progress. Not interested in warnings about shifting negative values. I am not interested in well, for starters, what the heck are you doing on line 32 that there's just not a semicolon? Well, you don't need a semicolon. That's that's not, you don't need a semicolon there. There's an open bracket on the next line. Compiler, what are you doing? It's just a function. This strong alias thing might be kind of annoying, though. Hey, Egoist. How are you doing today? Strong alias. I think it was in CDefs again, right? It was in CDefs. So I am doing good. We are, I don't know how long you've been here, obviously, but we are just trying to bring back, I used to have a math library, right? libm, the C math library, in the Nightingale repo. And I got rid of it approximately 1 year ago, saying I would make my own. And the thing that I did not fully appreciate was just how big the math library really is. I was hoping that most of these things were just CPU instructions, that, tangent, there's definitely like a floating point instruction for tangent. No, there super isn't. These are all ridiculously complicated, so I've decided to just bring it back. So I am wrestling with getting it updated to the new build system. And hopefully if we do that, what would be really awesome, I used to have Lua, the Lua programming language, running on this operating system using this math library. We might be able, probably not today, but we might be able to get that back, which would be really cool. But right now I'm in C preprocessor hell, which is really not the particular brand of hell that I wanted to live in. And I think a lot of why I'm in C preprocessor hell is that we have this same file, this source/cdefs.h, sys/cdefs.h, and we have a version of that that's defined in the libm library, but I also have a version of that in my system. I don't know what needed it, but I needed it for something. And I feel like some stuff is pulling this one and other stuff is pulling the other one. So I almost wonder if we could just remove it, because it's empty, right? I clearly don't need it for anything other than it existing. What if I just deleted it? Well, so far that's encouraging. Oh, you're kidding me. Oh, you're kidding me. Well, that's an entertaining problem. Yes, compiler. Complex numbers are indeed an extension in a freestanding C99 implementation. I do understand that, but you see, I'm trying to implement them. I'm trying to do the extension, and this isn't even a warning that I can ignore. This is just wpedantic. If you use complex numbers in at all, I think I just have to give up on pedantic, which is really upsetting because I like pedantic, because I like feeling like I'm a language lawyer. I wonder if I can just do that here, and hopefully I'll be able to keep it for the rest of the project. I really don't want to lose pedantic. Again, with the encouraging, we're not building complex yet. We are now building complex. I think it built the whole thing. Hey, sweet. Let's see that it actually put a library in the sysroot. It actually put a libm in the sysroot. So let's... then there's one more thing we have to do, which is we have to install the header file. How do I do that? Install directory include destination CMake install prefix. Install directory include destination CMake install prefix. Maybe. That should be all I need. No, hello. Okay. Include. Actually, that is not all I need. Okay, I think that worked because that installed some files. Do we have a math.h? We have a math.h. Okay, so then the one other thing that I do need is I need this to be accessible for the rest of the system. So like I need to symlink them or something into the include directory, because I need, or I need to just add this. Maybe I should just add this as a normal. Actually, that's what I should do. I should add this as an include directory to everything. We should say include directories are the binary directory include and external libm include. And then we should just make sure that we don't have anything mathematical in here. And we do not. There's no math.ah, there's no complex.ah, there's nothing in include that would be mathematical. So now we should be able to compile this program again, which hasn't worked for a year because I haven't had a math library. Okay, we changed the headers, so it's going to have to rebuild everything inside the kernel again. And inside the user mode. It does not like syscdefs. It include complex in... Oh, interesting. Okay. So this source cdefs is the thing that I was hoping. It's definitely not necessary though. Let's just get rid of it and see what happens. Hey. All right. It's still upset about pedantic. I think the answer is just going to be, we're going to say that user and the kernel is pedantic, but user mode is not. File, because I don't want to. I don't want to do this program by program. It is going to fail. Here, not here. Okay, same problem inside of math.h. Is there anything here that needs to come out of cdefs? I doubt it. We're gonna hope not. We'll see. And there's probably, I mean, there's more headers. I'm not importing any of the other headers. Yes, I am. Include _math. And of course now it's got to do all of this again. Invalid suffix di on floating constant inside user MB. At least it's my code. Why is this di? I mean, it should be d times I, right? I think I was just relying on... Well, it shouldn't even be d. It should just be 1.0 times I. I think I was just relying on some bad... Non-void function does not return a value. And we don't have symbols because we did not link it. But you just wait. This is going to be awesome. Oh no. Wait a minute. In MB iters, mul-dc multiply double complex. Surely that's in libm, right? Surely that's the whole point of libm, is that you get I guess I need compiler RT. How do you link compiler RT in Clang? I don't want to build it. I super duper duper don't want to build it. Clang. Shouldn't you link this automatically? You tell me that I can just dash L compiler RT. All right. Let's try it. Somehow I doubt it's going to be there. Yeah, it's super not. Okay. See if we can find a file named that. And was it? Oh God. So the thing that's happening here is that the compiler cannot output code for multiplying two complex numbers. That's not, I mean, there's no assembly instruction for that. So there's no file called test.c. So how could there be a swap file for it? Let's just delete it. Okay, I guess I have to delete it manually. Okay. So if I, just on my host system, if I include complex, and we do some complex math, and we don't optimize it because it would definitely just constant fold that if we did. And we take a look at that assembly, there's no instruction. Yeah, there's no like compiler instruction that it can use to say do a multiplication of two complex numbers. There's no complex numbers in registers. It just doesn't. So the thing that Clang and GCC do is they have these routines. Obviously, this is looking, I mean, it's a program that uses XMM registers. Even though this is not optimized, it still looks ridiculous. But it's calling this function called _muldec3. That's the thing that we just had it complain about in the kernel. But because this is a hosted system, it knows where to find that. And here's the implementation of muldec3. Well, it looks a lot like this. And I bet if I really wanted to, I could probably just like lift this assembly code and it would probably work. But I'm not going to do that. The thing that I want to do is, now that I have an invocation of Clang that definitely finds it, is I want to just turn up the verbosity screws and see if we can't figure out where it is linking in. So it might be this LGCC down here, and we can try that definitely in user mode. It's definitely called GCC calls its compiler RT equivalent. GCC calls it libgcc. And so Clang may just be copying that behavior, but we did not find library lgcc. So we need to tell it where to look for that, and that may be challenging if, right, you see where it's looking for various things here is in user bin libgcc. It super can't look there because I don't, or sorry, libgcc x8664 GNU, which is super not going to work for LLVM. But we could look in a place like this, like, right, user lib LVM10 bin might have something useful, or lib. Didn't really want to go there, but I guess that's fine fish. So do we see anything that looks like a libgcc, or not really? We could also do something like string star and grep for, just to see if it's in any of these. It is. One of these contains that symbol. It might not be as an export. It might be an internal thing. Libclang maybe. Let's see if we can figure out which one that was. I guess we can just grep it. Binary file lib clang 10.0 lib linux libclang rt built-ins. Okay, well, I don't want the Linux version, so I might have to figure out how to build libclang rt for my operating system. Is it -rt? It's _rt. How would one cross-compile libclang rt? For ARM, but maybe this will help. Compiler RT sources. Oh gosh. I really didn't. I mean, the whole point of using Clang is that you don't have to compile stuff, but maybe we will have to. Well, how do we build? How do we get it? Here. Let's see. Make or build. CD build. C make. Enter build. CD build. C make. Hopefully this doesn't require the LLVM source. That would be really annoying. Just because LLVM is such a ridiculously huge project with just unbelievable amounts of... Well, it takes... The thing that I really complain about is that it takes like... It takes something like 60 gigabytes of RAM to compile Clang, or to compile LLVM. Because the output file, at least for a debug build, the output file is just so large, and there are so many intermediate dependencies. Helpful. Are there versions? There are not versions. At least not in Git tags. Are there versions at all? GitHub LVM Mirror Compiler RT. Ah, good. Hasn't been updated in years. Okay, okay. Really helpful. Moved into LVM project. I don't want to check this repo out. That's the whole point. I don't want to have to check out the whole repo just to get this, because this repo is too big. Really dislike the fact. So I would really like to be in the habit of saying rm-r so that things that are really write protected don't get deleted by default. But the people who write Git have decided that their internal objects, because they're read only, they shouldn't be written to, that they should set the permission bits that they are literally read only, that they're like protected by policy read only. But those things are not the same, right? Don't write to this and the permission bit that says write to this are not the same thing. And what it means is that every time you're in a Git repo, you always have to do rm-f, rm-rf. So you can't even, like, I deal with enough Git repos that I can't get myself out of the, I mean, you see how well I've done. Even for having to go to RF almost every time, I still have the muscle memory to do rm-r, but it's just, it's such a bad decision by the Git authors to make their pack objects Unix permission read only. And now I've highlighted that, so I lost my clipboard. Copy link. This is why I didn't want to clone the LVM repo. Just downloading the current state in a zipped format is 70 megabytes, 80, 100 megabytes of source code. Like, what are they doing? How is LLVM now 150 zipped source code? I don't get it. 200 megabytes is the final tally. Do I have unzip? I do. Just an ungodly amount of source code. We'll be here all day. It's an interesting situation, though. If okay, let's see. Maybe this one will just work. It's an interesting situation, though. If Clang is gonna make me compile parts of the compiler, I may go back to GCC. The entire reason, the only reason that I am using Clang is that, well, that's even worse. All right. So that's an unsolvable problem. You know how that problem does get solved is by building GCC, because I know that works, because that's what I used to do. Shall we see if that still works? I've still got the patches. Do I still have the script? I do. Do we think it works? Oh, that's the wrong script. Do we think it works? We need to make sure we have these devel packages. Oh god, this is a 1-core VM. This is going to take forever. I'm not doing this right now either. Well, I'm sorry guys. I don't think we're going to be able to have the really cool payoff because both GCC and Clang are impossible to solve. The really cool payoff was going to be that this is this really, in my opinion, very small C program. It makes a Mandelbrot set. It's a really cool terminal UI Mandelbrot set with these characters, right? If it's outside the set, it's blank, and then it's got these like descending darkness characters for, you know, how far inside the set it is. It's really cool, and it's awesome when it's running on the system. And if I had done it, honestly, if I had done it not using double complex, if this was done using just like two-dimensional, you know, basically matrix arithmetic, it would have worked. But I also, that would be a lot longer, right? The thing that's really nice about double complex is that you basically get, you get 2D vectors and linear algebra for free, or at least with the default syntax. But alas, it looks like we're not going to get it right now. Not without me figuring out how these things work. We did still get libm, so that is nice. The problem is not... the problem is specifically... I mean, I'm kind of curious to know what's going on inside of libm, that they're doing all of this complex code and none of it multiplies two complex numbers ever. Well, obviously serial is not gonna, but like complex cosine, well, okay, complex cosine, yeah, it's just cosine of real plus sine of, sure. What's something that looks like it should do? How do you do complex exponentiation without any multiplication at all? You separate them into real and imaginary, and then you do it in regular numbers. And say W is, just add the ion at the end. All right. Well, let's get rid of MB, because we can't build that right now. Let's not link to GCC, because that doesn't make any sense. Let's not link MB to libm, because that doesn't make any sense either. Did I have anything else that used math? Let's make something that uses math so that we can at least get some payoff. Specifically, I've got this floating point program that just checks to make sure doing floating point in user mode works, which is non-trivial because different the floating point unit is not part of the normal CPU context. You have to save it separately. So when different threads are doing floating point stuff, it's interesting to know that they're not stepping on each other's toes. But let's have this do some more interesting stuff. Right now it's just literally like add, multiply. Let's do like a sine wave. And it'll be interesting to do this in 2 threads at once. So we're gonna make it a for loop. Or a while loop. Let's make this 0, and then every time around we're going to print, ooh. I definitely can't print floating point numbers though. I wonder what happens if I try. Let's find out. Sine L of x, and then x will increase by some small amount. And that's plus equals. We need the link. Is it not sine? Oh, it's just sine. Because it's the functions that take a double are just called the thing. The functions that take a float have an f on the end, but this is a double. And then user cmake float m. And that builds. Hooray. It's a little too fast to be a sine wave. Also, when did I implement printing floating point numbers? What? 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 If not kernel, format float, fractional part is value times 1,000. All right, I guess I did do that. I'm so good at this. If format plus, wow, we really didn't do a lot of these options, because there's definitely a lot of format options that I did not. I mean, we can fix one of these right now. Wow, that's actually really... No, it's not really bad. I thought for a second this meant that I was always putting a plus, so that if I was going to print plus, it would be like plus minus 10.0 or something like that, but it's not. It's a little less terrible than that. Oh yeah, I wanted to make it slower. 0.01 was too much. Or we could honestly, like, I don't think I can do a sleep for a partial. Yeah, you can kind of see that it's going up and then going back down. You probably can't see it on stream because this is going to be moving too fast for the compression, but it kind of looks good. Oh, I know what we can do. We could we can really print a sine wave. That's what we can do. We should print we should take this, so it's 80, the screen is going to be, I mean now it's obviously more than 80, but let's call it 80 columns wide. So 40 times sine x plus sine is -1 to 1, I think. I don't think I saw that in the output, but it certainly should be that. Let's see if we get the right thing. And then the thing that we should print is this will have to be converted to an integer, and then we should print that many spaces. So we'll just limit that with dot star s, and then a star. And now it should print a sine wave. Hey! Sort of. Alright, so it's definitely... Now it's 2. That's, I mean, it's definitely like bouncing off 0, right? It's not going negative, which is not great. Right, like, what's a sign that should be negative? Sine starts at 0. It goes positive for pi. So like sine of 4 should be negative. There's no reason for me to... Yeah, that's definitely not right. I wonder if that's the printing or if it's the... I mean, that sort of feels like... I guess the next question is, does math work on this at all? So if we said sine of 4.0, if x is greater than O, error. So we should definitely not see that. And that'll tell us that it's just the printing that's wrong. I typed that too fast. Okay. Yeah, okay. So it is just the printing that's wrong. Because it is definitely less than 0. So why are we printing that wrong? Int part is cast to long of the raw value. And print that as li. Is int part less than 0? Nope. So where's my minus sign? Oh. I know what the problem is. So the way this is printing, oh my God. The way this is printing, right, I'm printing the integer part first, and I'm relying on that to be negative, right? And the integer part of negative 5 is indeed negative 5, right? The integer part of negative 5.5 is negative 5, so it would print negative 5. Fractional part, absolute value of that times 1,000 mod 1,000, negative 5.500. It would print the right thing. But this number is 0.5, negative 0.5. So what am I asking it to do? The integer part is 0. And I'm printing exactly that. I'm printing 0.500. So the whole approach is wrong. Really, we've got to track the minus separately. God. I mean, this whole thing was like banged together to debug something. Obviously, I mean, this is terrible, right? This doesn't do any of the formatting that it should do, except for print plus, which is such a bizarre inclusion. So so then that's another sort of interesting question. So we've confirmed that the number is actually negative. Why is this wrong? because this, right, I said sine of x plus 1, so this should be from 0 to 2, and I multiplied it by 40, so why was it hitting the sidebar? I mean, let's make it smaller. Yeah, see, it's not, it's like going through. If I understand it correctly, it should be, I mean, we can just find out if I understand it correctly, so we're gonna print out two things. We're gonna print out I and LF, and the I is going to be this, and LF is going to be 20 times, honestly I should factor this out, double pos equals 20 times sine x So that should give us some indication of what is going on. And I want to make this even faster so that I can view the output a little faster. Still doing that for some reason. Don't know what that's about. Okay. So we see that it comes in at very high. Oh, no, this might actually be right. It's just, it was moving so fast, it didn't look like it was. It's doing what it should do. Just really, we should probably make this plus like 1.5. And if we do that, and we pad this, because the LF is always going to print the same amount, so we could pad this to 2 digits, and then we could put all of them together. And we could print the whole thing on one line. Int pos, int pos, O2I LF percent dot star s. And then our string, which is ridiculously long. And then it should be really cool. If it doesn't keep doing that for some reason, which I still need to figure out. We didn't print our star. Hey, there we go. I don't know how terrible that looks on the stream, but looks like math to me. Hopefully with it stopped, that's actually resolving a little clearer. Cool. That's cool. We got libm back. And now that I have a real build system, it's not going to try to rebuild itself every 2 seconds, except every time I commit, which is going to be annoying, but maybe we can fix that. I wonder if we can find an answer. So CMake is currently rebuilding the entire project every time I commit. CMake rebuilding all files when only one has changed. CMake rebuild triggered if git commit is more recent than timestamp. I worry that it's because of this variable, this that I take the version, this execute process, that I take the version from the get describe command. I wonder if we can just maybe during development, I should just turn this off. Well, okay, I'm not going to... The only way to test this would be to make a commit with it off and see, which I really don't want to do. The whole point of this is to get describe outputs the current version, basically. So this is saying the current state of the repository is version 0.12.6 plus 12 commits is what this means. This is 12 commits after the tag version 0.12.6, and the git commit hash of the current state of the repository is A123EA1. And I put that in my boot sprawl right here. Nightingale operating system version 0.12.6 12 GA 123A1. And so if you were to go to if you were to download one of these and run it, obviously this is not very helpful to me right this instant, but if you were to go to one of these releases tags and download the ISO and run it, it would show you the version that you are running off of, and you would be able to associate that back to the code. If somebody found a bug and reported it to me, they could include this, and I would be able to associate it with an exact version in Git. So it's nice to have it there, and I do like it, but it's also kind of annoying that it makes the whole system rebuild every time I commit. But that said, I think we are pretty darn close to being able to commit this. We got rid of that compile option. We added an include directory. We added a subdirectory. We changed assert.h because it needed to be changed. We deleted source cdefs and everything is fine. We made user non-pedantic. We made float linked to libm. We changed float dramatically. And we added external libm. I think that's one commit. I mean, it's changes necessary to add libm, and then the MB changes are a little unfortunate, but I think they're kind of necessary. And then we've got all of this in the new files. But it shouldn't actually take up any more space because the Git repo already has these files in it. I deleted these files a year ago, so now I'm just bringing them back, and so they shouldn't actually take up any space at all. Libm's triumphant return. Sortix libm's triumphant return. My hubris was too great, but I have been humbled. Which is going to lead to a great commit history on external libm. Move external code to external, replace the build system, remove libm, I'll write my own. My hubris was too great, and I have been humbled. 1 year and 1 month later. And now it's going to rebuild the entire world for the new version number, as discussed. Should we try for the bifecta? I am getting hungry. I haven't had dinner yet, and it's almost 9 p.m. So I'm I don't have forever, but I think there's a very real possibility that we could bring back Lua today. I think it's very possible. So the last time we saw Lua was 7 months ago, which is kind of weird. I would have expected it to go away at the same time as libm, but I guess maybe my hubris was so great that I thought I could make a libm good enough to run Lua. And so let's see what we can do about this. We will definitely need to add to external cmakes, add subdirectory, Lua. I know that this works at least well enough that I used to have it working, so I don't expect to have to do like porting work in Lua. There's already diffs in this implementation of Lua from fixing things like problems in my C library. But we will need to change the entire build system because Lua uses makefile, and I am not all about that life anymore. But it should be very easy, really. It should be very, very easy. Don't need to care about any of that really at all. It's this makefile that's interesting. And they've got the full dependency tree marked out here. Like the Lua people have done a really good job of being very intentional about their makefile and making it a really good makefile. But I don't want to use make. So the C flags that we care about are basically nothing. I think we're going to try, we definitely need to link with libm. I think we're going to try to just not bother with any C flags, and we'll see if we really desperately need this Lua compat 5.2. The code that we are linking together, I'm gonna guess is just all of the C files. That's gonna be our sort of first assumption. And if that ends up not being true, we will do more in-depth debugging. But the first thing we're going to do is just set like Lua sources, just like we did for libm earlier. Now we just have to get all of the sources. So that's the list. And we're just going to make sure that we're in external Lua so that we get a sort of reasonable view on that. And we also obviously only want everything whose name ends in C. And that's our whole sources directory. We said we are not going to care about any we're not going to care about any other flags. We should be fine. I think I actually set my no pedantic flag in here, so we might need to add things like no warning compile options, but we're not going to worry about any of those right now. We definitely want to include the source directory as an include directory because there are headers in there that will need to be included. And what else? Well, we need to make it an executable. How do you do that? You do it like this. Add executable and target link libraries, and then install. So so let's just grab all of this. Executable is called Lua. Lua Sources. We are linking to library C and library M, and install targets runtime destination bin. Okay, good start. No, that's not a good start. That's not even right. That's also a good start. Okay. This was me running the make file inside of the Lua directory, which is super definitely not what I want to do. But why are we getting big boom on attribute no return? This shouldn't be a problem. I'm kind of surprised that that's an unknown attribute, but I think the thing, it shouldn't be a problem because this is just, all this is saying is they tried to apply, right? Lua L no ret is trying to apply the double underscore attribute no return, and the compiler's being nice and telling me, well, I didn't know what that meant, so I'm not going to deal with it. It's only an error because I set W error. So I don't actually care about that. I just care, I don't care that it's ignored, right? The fact that there was an attribute no return is not going to change the way the function is generated. It's not going to change the way the function is executed. So we are going to just tell it that we don't care. And we're going to do that by saying add W no unknown attributes. Do not warn me about this problem. I expect we'll see at least one or two more of those because my warnings are more aggressive than the built-ins. Yep, here's another. String plus int. Adding int to string does not append the string to an int. Well, yes, I know that. This is trying to move it. Yes, you would like me to do this, but I'm not going to change the Lua code. I'm just going to say no W string plus it. This is totally valid C code that Clang is trying to be nice, and it's actually being unhelpful. So I'm just going to tell it not to bother. We got to 22 of 37, so we're more than halfway there. 30. Okay. Failed. Why? Duplicate symbol main. Okay. So, right, because two of these files are both binaries. Lua and Lua C are both binaries. I don't need Lua C. And that build could not find symbol start, which is a little concerning. That's not going to work. It did not work. This really shouldn't be necessary. Hey! Well, womp. We got Lua to start. It's not liking something to do with my input buffering again, which, to be fair to everyone out there at home, this is a problem that I have had a lot with Lua, is that, yeah, so some stuff is going to work, but that doesn't. Just hitting enter isn't working. Because Lua does some complicated input buffering stuff, and I'm doing complicated input buffering stuff. So I will definitely be spending a long time like doing this and staring at what it's actually reading and writing and trying to figure out where it's getting an unexpected symbol. Like it's reading, why is it reading? It's reading the 1 byte, and the 1 byte is the enter. So why does the Lua input buffer, like what am I doing differently than Linux? I don't know. For now, Lua's back, baby. Does it work? Maybe not. But it's here. Should it be in the repository? Probably not. Should there be like a ports thing? Probably. I didn't because it was very old, and I'm not going to do it now because this is already, as I said before about libm, if we run the, not nightly, if we run the git list largest files in, was it pack, I think? How do I identify large commits? This thing. Git rev list objects, which will list all of the command substitutions. Bash. So this is everything that's in my repo, or at least all the big ones. These are all the big files. Because the way Git works is every time you commit a changed version of a file, Git stores the entire revision for all time with an asterisk that as stuff gets really old, it will start to do stuff like compress and deduplicate. But essentially, if you commit a large file to Git, it's there forever, unless you rewrite history and that changes all of the hashes and stuff. So, for example, you can see that my history contains, I wonder which large file I edit the most. It contains about 1,000 copies of kernel/thread at slightly different sizes. And that's like the vast majority of the large stuff. That's hilarious. It turns out I do make a lot of changes to this file because all problems are concurrency problems. But the thing that this means is, for example, this file, external lua.contents.html, which has this hash, was already in my repo before we did this. So me putting it in the working copy doesn't change anything. It was already in the repo. It will always be in the repo unless I like completely rip the history out of this repo, which I don't want to do. It's got 1,500 commits in it. I want to see that history. And it's not even the biggest problem, because if we go down here to the bottom, we can see my oopsies, which are again here for all time. That here is a 600 kilobyte copy of the kernel in binary format that I committed at one point. And here is an 800 kilobyte version of Lua C, and here's a 900 kilobyte version of Lua C, and here's a 1.3 megabyte version of Lua, and here's liblua.a, 2 megabytes. This time I committed the entire init file system. God knows when, but somewhere in my history will always live. This repo will always have 4 megabytes of my stupidity in it. And we just have to learn to love ourselves and be happy. Thank you for the follow, NemPK. I suppose you appreciated the rant about file sizes. Appreciate you. I'm glad you're here. Hope you're enjoying. How big is this? It's 93 megabytes. It's getting up there. But that includes all the build assets and stuff. So 52 megabytes in build. So, you know, it's only like 40 megs. If I'm going to sit here and complain that the LLVM repo is 200 megs compressed, I should at least be able to back it up by saying that I'm a little bit smaller than that. Maybe not enough. And of course we committed, so now we have to rebuild the world, and rebuilding the world is really getting slow on this one core virtual machine. So I may have to just upgrade that, because if we're actually going to keep libm, and this, so definitely an option, definitely something I can do is make these conditional. And this is what I always wanted to do in the past, was have like a build condition that said, do you want to build libm or do you not want to build libm, so that I wouldn't have to do this every time. Because that was, I mean, let's find out how long that took. A long time for sure. While we do that, let's make sure that this is actually passing in GitHub, because that would also not be fun. Yep, cool. Not that I really expected it to be a problem, but it definitely, I mean, that the GitHub Actions builder is definitely a different environment than my computer, so there could have been some dependency problem, or maybe the version of the compiler is slightly different. Maybe there's a different warning or a different error. It definitely could have been a problem, but glad that it's not. So full rebuild, 40 seconds on a single core. I mean, it's not, I don't like it, but it's not terrible, I guess. Well, yeah. I would try with more cores, but I'm not going to spin up another VM right now. I'm not going to, well, I'm super not going to, because I'm not going to stream me logging into my VM dashboard. That would be a really bad decision. But, like I said, I think this was a very successful day, at least as far as the stuff that we wanted to get done. At the beginning, we definitely got that second core. It's definitely running. For anybody who missed that, it turned out that I was just really, really dumb, basically. I was spending, there you go, CPU 1 is sitting at instruction pointer 3. It's waiting for me to do something interesting with it. It turned out that if, for anyone who was here for the stream 2 days ago, when I was beating my head against trying to get that to work, it was just that I had fat fingered the address of the APIC. I was just writing to the wrong memory the whole time. And then spent 2 days reading documentation and taking notes and trying to find anything that I could do to make it different. And I was reading other people's code, and I couldn't find anything. And you know, copying functions from other operating systems, and it's still not working. It's because I had the address wrong. So we solved that, and we got Lua back, and we got libm back, and that's really awesome as well. So I need to have dinner, or I am just going to get hungrier and hungrier, and the stream will make less and less sense. But I hope everybody has a great rest of their day, and I will see you whenever I do this next. I don't know what that's going to be. Bye.